Assalamu alaikum. My name is Haseeb Yasir, and today in this video we are going to discuss our project report of microelectronics and embedded system, which is line follower and obstacle avoider. So here is the block diagram for our robot. We are using Arduino Atmega 2560 in our robot. So here is some pin configuration and detailed block diagram. First of all, here we have the battery source or supply, which is connected in series with the current sensor, or it is connected to the voltage sensor. Then current sensor is connected with A1, which is the analog input pin of Arduino ATmega 2560. Then voltage sensor battery supply is connected to voltage sensor, and it is also connected to the analog input pin of Arduino ATmega 2560, which is A2. Then here we have the digital pins for our IR sensors. Basically these IR sensors are taking input, so with the help of this IR sensor our robot is making decision to move or keep its track on the black line. So here we have the 6 sensors. The 6 sensors are named in the following manner. First of all, we have extreme left sensor, then we have left sensor, then center left, then comes center right, right sensor, and extreme right sensor. These IR sensors are taking input and they are connected to the digital input, which are 22, 23, 24, 25, 26 and 27. Then here we have the encoders. These encoders are basically used to measure the RPM of the motors. They are basically tachometers or speed encoders. They can count revolution per minute. Basically they are attached or they are kept. They are non-contact encoders, and they are kept on the upside of the wheel or the slit, which has 20 slits in it, or it counts the revolution per minute or the rotation of the wheel, and then it shows the RPM to the display attached. Here we have the two encoders. The first one is for left wheel, and it is called as left encoder, and it is connected to the digital IO 20. And then we have the right encoder, which is connected to the 21 pin. Then here we have ultrasonic sensor. In ultrasonic sensor we basically have 4 pins. First one is for VCC, and the last one for ground. Here VCC and ground are not shown as it is taken directly from the Arduino. Then here we have the trigger pin or echo pin. Basically this trigger pin is the in transmitter pin, and this echo pin is the receiver pin. This trigger pin creates or travel or from it travel the sound waves, and then it come back to the echo pin. So in this way trigger pin is acting as transmitter and echo pin is acting as receiver. Here we have the soft start button, which is connected to the 3rd pin. Then here we have our LCD display, which is connected to the following pins. In LCD we are using 4-bit transfer data mode. So first of all, here we have VCC, VEE or ground pin. VSS pin is basically, or VCC pin is directly connected to the supply, or ground pin is directly tied to the ground, and then VEE pin is basically the contrast pin, which is setting the contrast or controlling the contrast of this display. Then here we have RS, RW or enable pin. This RS pin is for sending data, and this ENF pin for enable. Then we are not using our LCD in writing mode. We are only using it to show the display or showing any information on it. So this RW pin is grounded. So then we have this D4, D5, D6, D7 pins, which are connected to 39, 41, 43 and 45 pin of the Arduino. These are basically data pin. We are using our LCD in the 4-bit mode. Then here we have the A or K pin, which are basically for the backlight of the LCD. The 5 volt is connected to the A and ground is connected to the K. So in this way the LCD is connected to our Arduino ATmega 2560. Then here we have our SD card, in which we have the 4th pin. These are the confirmed or the predefined pin for our SD card, and it is used for serial communication. First of all, we have MISO, MOSI, SCK and CS pin. MISO, SCK and CS pin are taking the output, and MOSI is used as input pin. So in this way this pin configuration are, and in this way it is connected to the Arduino. Then here we have our motor drive, in which we have the 6 pins. The 2 pins are for PWM, for controlling the PWM of the motors, and the 4th pin are for and the 4th pins are the output pins, which are used for running these motors in forward or reverse direction. This enable is for our left pin, which is connected to the 10, and this enable is for our right motor, which is connected to the 11. Basically these are the PWM control pins, and here we have the direction control pins of our motors. Here we have the 5V or VCC pins. 5V is basically sending its 5V pin is connected to the Arduino, and this motor drive is taking the 12V input from the battery source. And the ground of all the sensors, motor drive and all the Arduino grounds are short. And then here we have motor left and motor right. Motor left is connected to on the one side of this motor drive, and the motor right is connected to the other side of this motor drive. So in this way this complete block diagram is showing or presenting our complete line follower robot, which is working in the following manner. Now let's move to our code. Now let's discuss the code which we have made for our robot on Arduino IDE. So let's start. First of all, we have to include the library for LCD, which is hash include lcd crystal.h. Then we have sd.h library, and then we have spi.h library. These two libraries are for our SD card, which are necessary to include. Then here we have pin declaration. First of all, we have declared the pins for our sensors. Starting from extreme right sensor, we have defined the pin number 27 for extreme right sensor. Then for right sensor, pin number 26, for center right 25, center left 24, and for left center 23, and for extreme left sensor we have the pin 22. Then here we have defined the pins for our motors, which are for motor left forward, motor left backward, and motor right forward and motor right backward. The pins are 6, 7, 8, 9. Then here we have the PWM pins, or the speed control pins for our motors. For motor left we have the pin number 10, and for motor right, for controlling PWM, we have the pin number 11. Then here we have the 2 pins, which are the pins of ultrasonic sensor, echo pin and trigger pin. For echo pin we have the pin number 5, and for trigger pin we have the pin number 4. Then here we define the variable enable of data type integer, and we have assigned it as the value 0. Then here we have the pins for our SD card, which is int pin CS, which is pin number 53. Then we have the pins 50, 51, 52 and 53, which are reserved for our SD card, MOSI, MISO, SCK and CS. Then here we have file my file library. Then here for reading SD card. Then here we have the code for encoder. First of all, for encoder we have defined the pins 20 and 21 with name I0 and I1. Then here we have the variables with volatile int data type. First of all, we have the count 1 equals to 0 and count 2 equals to 0. These are basically to count the revolution and count the slit number, which are 20 slits on encoder wheel, to count the RPM for our motor. Then here we have the 2 variables with static data type, which are PM1 and PM2. Then here we have the 2 variables of integer data type, RPM1, RPM2. Then we have the unsigned long encoder check variable, whose value is 0. Then for LCD we have the pins, which are RS pin, enable pin, and the data pins, which are D4 to D7. Then here we have the LCD function, in which we have defined all the pins. Basically we have include the LCD library, so it is necessary to define or declare all the pins. Then here we have the unsigned long data type variables LCD check 1 and LCD check 2. Then here we have the pins defined for our current sensor. For current sensor we have the first pin, which is current pin of data type constant int equals to A1. Then here we have the float current value which is equals to 0. Then for ADC we have the temporary variable whose data type is float and its value is 0. Then we have the sensitivity data type whose is float and we have assigned it value as 100. Then here we have another ADC value for which we have assigned it as 0. These all ADC values are of data type float, which are offset voltage, ADC value and ADC voltage. For offset voltage we have assigned it as value 2500. Then we have our voltage sensor pins, which are voltage value, voltage and resistor. These are also float data type because we are using it in a analog pin mode, and here we have defined the value for RES 0.42. Then here we have unsigned long voltage check name variable whose value is 0. Then the pin for ultrasonic, which are duration and distance of long and int data type. Then here we have our all function declaration. We have made our code in chunks, like we have made all the functions for the respective part. First of all, we have here for the line follower, turn left, turn right, forward, stop and reverse direction. These all functions are working in our running of the line follower robot. Then here we have for motors M1, M2, for encoder, for LCD display, for voltage sensor, current sensor, ultrasonic sensor, and a function for obstacle check. Then here we have SD card function, which is taking the value of string path. Then here in setup we have our all pin modes, and we have defined all the variables as input and output. As our sensors are working as input, so we have defined them in pin mode as input. Then our motors are working as output, then we have defined our motors pin as output in pin mode. Then for our PWM pins are also defined as output, and our voltage and current pins are defined as input. Then here we have the trigger and echo pins for ultrasonic sensor. As I told you earlier, the trigger pin is working as transmitter and echo pin is working as receiver. So trigger pin is basically output and echo pin is input. Then here we have the pin mode for pin CS, which is working as output in SD card. Then here we have the LCD variable for which LCD functions, in which we have LCD.begin 16x2. Basically we have the LCD which is 16x2 LCD. It consists of 2 rows and 16 columns. And here we have the serial.begin, which is used for serial monitor to display the thing which you want to display on the Arduino display. Then here we have the interrupt for motors. And then we have here the line void loop, in which we have defined our line follower, call our line follower, encoder function and LCD display function. Basically these 3 functions are working in our loop. For outside this loop we have the SD card function and the remaining function of obstacle check, ultrasonic, voltage sensor and current sensor, because these are working in a parallel manner on our robot. So let's start first from the SD card. Then here we have our function definitions. First of all, for our SD card, basically SD card is our void function, which is returning nothing but storing the path which our robot is making, or on which our robot is traveling on the black line. So here we have void SD card, and it is taking path as argument whose data type is string. Then here we have the serial.print to check it on serial monitor that SD card accessed. Then if SD card, then serial print will take its input and read the SD card file, in which we have my file is st.open and pathlog.txt. The path which is stored on the SD card file will open as txt file, and we will able to read it on our serial monitor, or either on it USB by connecting it to the laptop. Then here we have the myfile.close library for closing the file which we have open. Then here we have if serial print SD card failed. If if there is no data on SD card, then it will show nothing on the serial monitor. Basically, it is working in a manner that first of all it will access the file, the txt file, then it will open it, and then it will read the data in the text file, and then it will going to close it. So the next function is our obstacle check function, which is working in a manner that if our ultrasonic is a function that if it is less than 10 and if it is greater than 0, then it will digital write, it will allow the extreme sensor to make it as low, and then it will call the reverse direction function. So basically this is working in a manner that if our robot detects some obstacle in front of it, it will stop, then it will turn 180 degree by keeping the robot moving on the white line as well, and then when it will come back to the again black line after 180 degree turn, it will keep its track according to the line. Then we have here ultrasonic function, in which we have our trigger pen, we are making it as low. Then we have some delay of 3 microseconds. Then we have again making our trigger pen high and for delay of 15 microseconds. Then we are making our trigger pen low again. We have the duration, which is the pulse input from the echo pin, and the distance is calculated by dividing the duration with 2 and multiplying it with the speed of sound in centimeter, which is 0.0334 centimeter per second. Then here we have the serial monitor, for which we have the distance which our robot has detect, and it will going to show it on a display serial monitor with in centimeters. Then we have our voltage sensor. Our voltage sensor is working in a manner that in voltage sensor we have first of all for loop, for which we have the initialize our integer I variable with 0, and it will going to work when the value of I is less than 200, and it is iterated or incremented in every iteration. Then we have our voltage value, in which we are going to we are going to calculate the voltage by the following calculation. First of all, we are taking the voltage input from our battery source, then we are going to multiply it with 5 as we are taking the external source, and then we are going to divide it with 1023 as it is in 10-bit mode. Then we have our voltage value. We are going to scale down it with the help of by dividing it with 200, and then this value is again going to divide with the value of the resistor, and then it will returning the value of the voltage. Then for current sensor we have the same for loop, which is going to work for the 200 iterations of the integer I variable. It is going to read the current from the analog pin. Then we have the temporary ADC value, which is going to store this value, and this value is going to be incremented it or going to be sum it when it will increase. Then we are going to scale down it with the same 200 value, and then it will going to show, we are going to show the value of the current by multiplying it with 5000 and dividing it with 1023. It is basically the ADC calculation which is needed to scale down the value of current to show it properly on the display. Then the current value, we have ADC voltage, which is going to be a minus from the offset voltage, and divide with the value of sensitivity, as we have already assigned the value to the sensitivity. Then again we are going to assign 0 to the temporary ADC value, and it will going to return the current value. Then we have our LCD display function. We are going to define our LCD display function, in which we have the unsigned long check variable with the name of checker2, and it is going to store the value of millis. Millis is basically the predefined function which is going to start or count the time from the start where our code is started, and it will going to store the value in microsecond. We are going to minus the value of this checker with the LCD check, and if it is greater than 600, then we are going to show the LCD following commands or data on the display. First of all, we have the LCD clear function, which is going to clear our LCD. Then we have our set cursor, which is going to set our LCD or our cursor on the 0th position. Then we are going to print on LCD RPM 1, and then we have the LCD set cursor for RPM, and we are going to store the value of RPM 1. Then again this millis function, basically this millis function are going to use to generate delays. They will going to make our code run properly without creating the disturbance for the other functions which are going to work without delays. So in this way we have, again for the RPM 2, we are going to display RPM 2 on the LCD and the value, its value from the RPM function. Then again for the current value and for the voltage value we have the same. Now this time we are going to display it on the other line. So we have assigned them the next value of the row and column, and we are going to display the value of current and voltage on the display. So in this way our LCD function is working. Then we have our encoder function. Our encoders are working in a manner that first of all we have the variable count, which we are assigned the value 0. Then we are going to increment its value unless it will reach the value of 20. Then same for the encoder M2, for which we have the count2 variable, and it will going to increment the value of the count2 variable. Then here we have the encoder main function, in which we are going to check that either the value of count is greater than 20 or not. If it is greater than 20, then it will going to enable it, and then it will going to count the RPM for our motors. This is working in a manner that we are going to minus the check value from the encoder check, and if it is greater than 1000, then we are going to divide it with 20, because there are 20 slits on our encoder wheel, and we are going to multiply it with 60 because we are counting the RPM revolution per minute. So we are going to multiply it with 60. So in this way the RPM is going to be shown on the LCD, and again with this thing we are going to assign the value for count of count 1 and 2 as 0. Now it will going to again increment it from 0 to 20, and when they are greater than 20 this thing will happen, and it will going to show the RPM for our motors. This thing is to check it the value of RPM on our serial monitor. Then here we have our main line follower function. First of all, it is checking the value of all the value of our sensors which are taking our input. So in this first of all, if our extreme right sensor is high, our all sensors are high except our two sensor, which is the left sensor and extreme left sensor. Then our robot will take turn to the left, as it is as it is taking the input from all the right sensor, and so our robot is going to make turn to the right. So for right turn we have to turn the left motor on. So in this way it will move in the right direction. Now for the second case, if our all sensors are high except our right sensor or extreme right sensor, then our robot will make turn in the left direction. Now our right motor will going to work and our robot will move in the left direction. Now for the following case, in which our all sensors are high and only the our central sensors are high, only central left sensor or central right sensor, and all the remaining sensors are low, then our robot will move in the forward direction and both the motors will move. Now there is some case in which all the sensors are high, then our robot will stop and no motor will work. If all the sensors are low, then again our robot will stop and no motor will work. If our following sensors are high, which are left sensor, central left, central right sensor and right sensor, then our robot will move right and the left motor will work. Now if our left sensors are high and our extreme right sensors are low, then our robot will move in the left direction with right motor working. So here we have the following two cases more, in which all the sensors are low except the extreme right sensor and the right sensor. In this case our robot will make turn right, and if all the sensors are low except central left or left sensor, our robot will move left. Then if any of these condition is not fulfilled, then we have the stop condition, so our robot will stop. For right turn we have the following condition. We are going to move motor left in the forward direction. If we are going to move if we are going to take turn to the right, and all the remaining motors are low with the PWM set as 80. So SD card will save data as right. If we are going to make the turn to the left, our right motor will work with PWM 80 and all the remaining pins will become low, and our SD card will store data as left. If we are going to move forward, then our all the motors left and right will going to be moved with the PWM 70, and in this case our backward motor pins are low and SD card will store the data as forward. Now for the stop condition, our all motors will stop or keep the data as low and SD card will store data as stop. Now for the reversed condition, we are going to pass the input from the backward direction for moving reverse and with the PWM as 80. So in this way, this is the complete code for our line forward. Now here is the schematic circuit for our robot. First of all, here we have our Arduino ATmega2560. Then here we have the all sensors which are connected to the respective pins. So first of all, starting from our IR sensors, so here is our IR sensors. From here we have the left sensors and the right sensors. So these are the 6 pins for our sensors. From from extreme left sensor, center left sensor, right sensor, center right sensor, right sensor, and extreme right sensor. And these 2 pins are for the VCC and ground for all these 6 sensors. Then here we have our voltage sensor. For voltage sensor, we are simply using the voltage divider made from the 2 resistors of resistances 4.7k and 3.3k. We are supplying the 12 volt to our 4.7 resistor, and we are checking the resistance to 3.3 resistor from which we are going to take the output. So for current sensor, here we have this. For current sensor we have this VCC pin and the ground pin, and the middle pin is for the input, analog input, which is taking from the Arduino. Then here we have our SD card, which is connected in the following manner. This pin is for MISO, MOSI, SCK, CS, and ground, and VCC pin. And these pins are the predefined pins on the Arduino. Then here we have our ultrasonic sensor, for which we have the 2 VCC and ground pins, and in the center pins are for the trigger pin and the echo pin. Then here we have our the pins for motors and extra supply. For we have the 2 VCC and ground extra pins or ports on our robot for taking the external VCC or ground. And here we have the pin configuration for our motors. For these 2 are for PWM pins, and these are the motor forward and reverse moving pins. Then here we have the pin configuration for our LCD. Here is the LCD. We are using it in 4-bit mode, so these pins are connected to the respective output pins, and these are for the VCC and ground to make the backlight of the LCD, to make the backlight on of the LCD. Then here we have the VCC pin, which is connected to the 5-volt supply. Here we have the ground pin, and the third one is the contrast pin. Then here we have the RW pin. RW pin is grounded because we are going to use our LCD only to show the information, and this is the enable pin. So it is a complete schematic circuit for our robot. Then here we have our PCB layout. We are using the single copper layer board for our robot, and here we have the only one jumper, which is for the contrast pin of the LCD. Here you can check the complete PCB layout. Here is the Arduino. Here we have the LCD. Here we have IR sensor for SD card, and here we have the voltage sensor, extra supply, current sensor, motors, and here we have our ultrasonic sensor and encoders.
अस्सलाम वालेकुम सर, ये हमारा अभी स्टेट कंडीशन पे है, ठीक है। अभी कोई मोटर नहीं चल रही, तो ये 0 आरपीएम शो कर रहा है, ठीक है। और करंट जो है वो 0.62 आ रहा है। बैटरी हमारी अभी फुली चार्ज है।
करंट
तो
एम्पेयर में है,
करंट हमारा जो है वो एम्पेयर में हमने चेंज किया हुआ है, ठीक है। तो यहाँ पे जो है वोल्टेज जो है हमारा वो भी फुल चार्ज है, तो 11 आ रहा है। अब ये है कि हम लोग इसको देख लेते हैं। जैसे कि हम यहाँ से वायर उतारते हैं तो हमारा वोल्टेज जो है वो 0 हो गया, ठीक है। अब हम इसको वापस लगा देते हैं।
ये नहीं आ रहा।
अच्छा, ये अब दोबारा वापस लगा दिया तो ये दोबारा वही वोल्टेज आ रहा है, ठीक है। दिखाओ
7 आरपीएम की वैल्यू दिखाओ। एक ही मोटर चल रही है तो सिर्फ उसी का आरपीएम शो हो रहा है।
अब देखो, अब दूसरी शो हो रहा है।
अब दूसरी मोटर ऑन कर दी, उसका आरपीएम शो हो रहा है।
अच्छा, दोनों ऑन करता हूँ।
अब दोनों ऑन है।
2 मिनट। ठीक है। और इसके अलावा अब यह है कि जब ये चलेगी, जब मोटर एक चलती है तो करंट बढ़ता है, वो दिखा दिया।
दोनों का आरपीएम इकट्ठे नहीं आया, दोबारा कर लो।
2 मिनट आ रहा है।
हाँ, दोनों मोटर
अब दोनों
का
मोटर
आरपीएम शो हो रहा है।
हाँ दोनों का आरपीएम शो हो रहा है।
करंट की वैल्यू भी बढ़ गई है।
ठीक है।